Hi everybody and welcome back. In this video, we're going to talk about a lab report format that's the standard format that we would turn in for a lab report. So first thing that we want to include would be our name, our partners' names, and when we worked on the experiment and the title of the experiment. After that, we would include the purpose or the objectives, which is usually something that the teacher, me, or whoever will talk about before we even begin the lab. And then you would talk about the procedure. So how was the data collected? Now, I put a star next to procedure because for our first lab, we're not going to worry about doing the procedure. That's something that we're going to look at later on. So you're going to be able to skip that for the first one, but that would be your next piece of the lab report. After that, you're going to include any data or calculations that you did with the data, and then any graphs that you created out of the data. And you're going to add commentary to the graph. So we're going to talk about commentary in a little bit. If there are analysis questions to the lab, that would be the next step. Again, I put a star here. We're not going to worry about doing the analysis questions at this time. And then lastly, we're going to look at the conclusion to the lab. So we'll talk about that as well. All right, so when you are recording data, my expectation is that you put all the data in a nice, neat data table, and that the table is labeled with units. All right, so if we're measuring force and acceleration, we're going to write at the top of the column force in newtons and acceleration in meters per second squared. All right, so whatever those units are, we want to make sure that we include them at the top of the column. We talked about not putting those units in the cells because of needing to graph them. So just make sure it's labeled at the top. We're going to add border lines to our data. All right, so when we go to copy it into the lab report, we'll add those lines in just to make it nice and neat. And we're going to pay attention to significant figures. So we want to make sure that the Google Sheets does not truncate the numbers and chop off zeros that are significant and things like that. All right, and we talked about in a previous video how to make sure that that was the case. So think about when you're recording your data, how much precision are you able to measure down to? Remember, the rule is measure down as far as the device will allow to the highest level of precision, and then estimate the last digit. So make sure that your data is consistent in that way with whatever device you were using to make that measurement. And keep in mind that not all of your measurements are going to have necessarily the same number of decimal places. If you use two different devices to make two different measurements, you might not have the same level of precision. So keep that in mind. Okay, and then for your graphs, once you make your graph and you're putting it into your report, I'd like you to resize it to about a half a page. You should definitely have titles and axis labels with units. If there's a trend in the data, that you include that trend line, and we're going to put commentary underneath the graph. So I want to show you an example of what I mean by that. Okay, so under the graphs from a lab, a few sentences discussing the following. So this is what you want to focus on. What's this a graph of? What trend do we see, if there is a trend? And how well does the trend fit the data? And does this make sense physically? All right, so those are the things you should be commenting on underneath of each graph. So I'll show you an example. So here's a good graph. Notice we have the title at the top. We have units on the side, so labeled, position with meters, time with seconds. All right, everything looks nice and neat. It's about a half a page in size. The trend line was added here. We can see that it's a curve actually. The equation is shown and the R squared value. So we want to make sure that all of that is included. Okay, and then here's the commentary. So it says above is a graph of the position of the toy car versus time for the experiment. So it's telling me what is it. As time went on, the position increased in a quadratic fashion. So what type of trend is it? That's what this talks about. The trend fit the data well with a correlation of 0.9929. We see that here All right, so that means the closer we get to 1, the closer the trend is to the actual data point. So that's a very good fit. It's very close to 1. And this makes sense because the car was speeding up in the experiment. So as it got faster and faster, it covered more position as time went on. Okay, so let's also talk about lab conclusions. And the first thing you want to do is reflect back on some of the things that you might have said in the graph commentary. For example, what trends existed in the variables and how strong they were, and what evidence supports this. So you might feel like you're repeating yourself a little bit there, but that's actually probably a good thing. All right. Your conclusion is basically your closing argument. So you presented evidence earlier, and now you're kind of encapsulating what does that evidence show. So it's okay to feel like you're repeating yourself a little bit. Next would be, how do these results compare to the original hypothesis? And what evidence do you have to support this? So when you talked about what you thought was going to happen, what sort of relationship we might have seen, is that what happened? Or is it something different? And what evidence do you have to show that? Do the results seem to be reasonable? And what logic or reasoning could be used to explain that? And what were any sources of error or uncertainty in the experiment? And how much of an impact did they have on the results? And try to be specific about this. Okay, so I have an example here. If we take a look. So here's a bad example. We learned that the higher we start the marble on the ramp, the farther from the table it lands. Errors were things like not measuring perfectly, right? This is a conclusion I've gotten from a student before, all right? If you think about the lab that we just completed with the range of a marble, rolling it down the ramp, you pretty much know that that's going to happen before you even do the experiment without measuring anything. You know, all right, if I raise it up higher on the ramp, it's going to land farther away. It's obvious. So this is a really bad conclusion because it doesn't tell the reader anything more than they already knew. All right, anybody with half a brain would be able to make that statement from like second grade on. So this is not helpful. All right, we need to get way more specific than this. So here's what I'm looking for. The results of the lab showed that there was a polynomial relationship, it's quadratic, between the range of the marble and its height. With a correlation of 0.988, the trend fit the data very well. So we're talking about a specific trend, how well it fit. This shows that as the height of the marble increased, so did the range, but they did not grow at the same rate. The range grew faster. Right, so we're just interpreting a little bit. Perhaps this is because as the ball moves higher on the ramp, on a higher ramp, it accelerates for a longer time, allowing it to go farther. So you're commenting there on why does this make sense or not make sense. The major source of uncertainty in this experiment was the ball bouncing on the table. This led to some inconsistency in the path taken and the ball's speed. But since the data fit a trend strongly, it is unlikely that this had a major impact. So notice this, it's not just like, oh, we might have made mistakes. Okay, we're talking about something specific, the bouncing on the table, that made it difficult for you to get good measurements, was inconsistent, but since it fits the trend well, we know that it didn't have much of an impact. Okay, so following a model like this is a way to write a really good lab conclusion. So you want to try to model it after this idea. We talked about what are we looking for on the previous slide. All right, so think about that when you are creating your lab conclusions, and that's going to get you in the best place possible. And keep in mind, anytime you're working on lab pieces, before you turn that in, if you want me to take a look at it, a draft, and make some comments on some areas for improvement, definitely ask, and I will go through that with you in class or after class, whatever. But you want to ask about that, and then we can move forward.